Hello students, this is lesson U5A05a. By the end of the lesson, you should be able to say I can solve for sides of 30, 60, 90 and 45, 45, 90 triangles. So let's take a look. I'm going to fast forward here to slide number 20. Here we go. All right, so the task here says to find the value of h in terms of a. So I have a right triangle. I actually have an isosceles right triangle. So what I want to do is, I notice right now that a squared plus a squared is equal to h squared. This is true because of the Pythagorean theorem. So the question is asking for us to find the value of h in terms of a, right? So therefore h, or 2a squared, is equal to h squared. Or in other words, h is equal to square root of 2a, or h is equal to a square root of 2. Okay? So in other words, okay, in any given isosceles right triangle, the ratio of sides will always share this proportion, where the two legs will be 1 to 1, and the hypotenuse will be square root of 2. It will always share that proportion. Let's do it again for this time a 60-60 triangle, right? But what we're going to do is we're going to take this equilateral triangle and I'm going to split it right down the middle. And why am I doing that? Well, that's because I want to form this 30-60-90 triangle. So now I'm telling you again, we first established that the equilateral triangle had side lengths of 2a, right? So now what we're doing is, because we're splitting it right down the middle, one of the leg will have a length of a, and the hypotenuse will have a length of 2a. I again want to figure out the side length h here in terms of a. So to do this, we're going to again apply the Pythagorean theorem. So we're going to say h squared plus a squared is equal to 2a quantity squared. We're going to square 2a to get 4a squared. Let's subtract a squared from both sides. We end up with h squared is equal to 3a squared. Let's take the square root of both sides. We'll end up with h is equal to a square root of 3. So what we end up with is a triangle with this proportion, a square root of 3, a, and 2a, or 1, 2, radical 3. So just be careful here, though, okay? The 2 in this case is the largest number. That is our hypotenuse. However, this is a convenient way for us to remember this ratio. It's always going to be 1, 2, square root of 3. But keep in mind, the 2 here, the number in the middle, is the hypotenuse. All right, so with that said, what do we do with this? So now that we have this understanding, okay, that that a 30, 60, 90 triangle will always have this proportion, 1, 2, square root of 3, and now I have this leg right here. This is 2, okay? So this 2 corresponds with which of the proportion here? That 2 corresponds with the shortest side, okay? So this corresponds with 2. And then the other side length over here, okay, this leg right there corresponds with the radical 3. And the hypotenuse here corresponds with the middle number in the middle. So if I multiply the first number by 2 to get 2, the second number should be 4. The third number should be 2 radical 3 then. So therefore, the hypotenuse must be 4, and the leg must be 2 radical 3. Let's try this again. Right, so again, another way of looking at it, okay? This is the leg, this is the longer leg, this is our hypotenuse. So a, therefore, here corresponds with 2. Okay, so if a is 2, then the other sides must be 4 and 2 radical 3. All right, so let's take a look at this guy. So I want to figure out what are the side lengths of YZ and XZ. So being that this is 45 degrees here, this angle must also be 45, which means this is a isosceles right triangle. So if this is an isosceles right triangle, then the side lengths must correspond with this ratio. So right now the 3 is actually corresponding to the hypotenuse, and I need to figure out what these other legs are, okay? So how am I going to do that? Well, I know 3 corresponds with radical 2, okay? And then these side lengths here, let's call that x or something, right? So I don't know what that is, okay? But what I do know is, okay, that 3 is to the ratio a here that I'm going to multiply. I'm going to call that a radical 2. So immediately I know that, I'm sorry, this I should call a. So immediately I know that a is going to equal to 3 over radical 2. Now there's something in math we called rationalization. Okay, so what exactly is rationalization? Whenever we have a number, okay, where there's a radical in denominator, we gotta not leave it there. We gotta clean it up a little bit. We can't have radicals in the denominator. So to get rid of the radical in denominator, we're going to multiply both the numerator and denominator by whatever the radical is in the denominator. So here I'm going to multiply by radical 2 over radical 2. And if I do this, the radical in the denominator will then therefore become positive 2. The numerator I will end up with is 3 radical 2. So a therefore is 3 radical 2 over 2. And this guy here is also 3 radical 2 over 2. All right, let's try this again. Pause the video to see if we can figure this out. Hopefully you had some time to think about this. So what we're going to take a look, what we're going to do now is I immediately notice that the 6 here, okay, corresponds with a radical 3. Okay, so because the 6 corresponds with a radical 3, this guy over here is a, and then this side over here is 2a. So I need to figure out what a is, in other words. So a is equal to 6 over radical 3. And we got to rationalize, remember? This is the same thing as 6 radical 3 over 3. So if a is 6 radical 3 over 3, then that means PR is equal to 6 radical 3 over 3. PQ is equal to 2a, so therefore PQ is equal to 12 radical 3 over 3. Right, I forget. 6 radical 3 over 3 can be reduced because 6 over 3 is 2. My bad. And 12 over 3 can be reduced to get 4. Okay.